Hi guys, so now we're going to go on to the adaptations of the energy systems. Now, hopefully you understand through the fact that we've done it with the skeletal system, the muscular system, the cardiovascular system, and the respiratory system, that after a kind of significant period of time, so a few weeks, a few months, of a good detailed program, you're going to get specific adaptations to our specific systems. So we also need to do this with regards to the energy systems, okay, and that's what we're going to be touching on today. Again, when you're looking at a question, you've got to look at the mark allocation, circle important information, using the memory method, translate that memory method, and then hopefully explain with an example. These are the adaptations of the energy systems, okay, with the fill in the gaps. So pause this and give this a go. Right, okay, I'm going to go through the answers now. You should have increased creatine stores, increased tolerance to lactic acid, aerobic energy system, increased use of fats as an energy source or increased use of fats, increased storage of glycogen, and increased number of mitochondria. They are the adaptations of the energy systems. Now, if you need to go back over them in more detail, then look at the PowerPoint that is on Moodle to help you out. I'll briefly go through some of them now, and you might have to jot down notes, but they're not going to be on the screen or anything like that. So, increased creatine stores. We're able to do this with short duration interval training sessions using high intensity. It's really important that you know that it's high intensity interval sessions help increase our creatine stores. This improves our ability, well, our anaerobic capacity, doesn't it? So with a 100-meter sprint, for example, it would increase their performance. A shot put would increase their performance, and so on. It's important that you know that the more creatine the muscle, it'll improve the ATP-PC system, okay, and that's the most important part of that. With regards to increased tolerance to lactic acid, the body becomes kind of more efficient at removing waste product. So as you're running during the lactate system, which lasts from 10 seconds to 2 to 3 minutes, what would happen is you're able to perform at a higher intensity. You're able to run actually like faster because when you're producing waste product, your body is able to actually remove that waste product, that carbon dioxide, at a quicker rate. So that's probably due to other adaptations of the cardiovascular system, such as capillarization of the skeletal muscle, and then with regards to the respiratory system, adaptations of increased strength of the respiratory muscles, i.e. we're getting more oxygen on board. We're getting more oxygen to the muscles because of the amount of capillaries we have, the increase in blood we have, the increase in stroke volume that we get, and we're able to breathe out more carbon dioxide once again because of that thoracic cavity increasing. So hopefully you can see how it's all linking together when it comes to the energy systems. This increased tolerance to lactic acid means we're going to be able to perform for longer at higher intensities, reducing the effects of fatigue. So with regards to aerobic energy systems, that's the third one. The cardiovascular system has a lot to do with this in terms of cardiac hypertrophy occurring. This means increase in stroke volume, a decrease in resting heart rate, decreased recovery time, capillarization, and increased blood volume. That's going to help with the aerobic system because it's all about the delivery of blood, the delivery of oxygen to the working muscles, and the removal of carbon dioxide. Increased use of fats. This is going to be beneficial for a long kind of distance athlete who's going to need more energy. As you saw from the previous screencast, 36 to 38 mol of ATP are produced from the glucose during aerobic endurance. However, from fats you get even more. And what else happens is because you're using fats, you're actually saving your glucose and glycogen. Now, hopefully, you understand that the fuels used for the lactate system is glucose and glycogen. That lactate system you can use for about 2 to 3 minutes, but that's anaerobic, it's high intensity. So that period during a marathon where you go to take over an athlete and then you want to actually extend your lead, that would be using your glycogen and glucose. Now, the more you're using your fats, the more glucose and glycogen you're going to have. Therefore, the more kind of opportunities you're going to get to overtake, to kind of carry on your lead, and for that sprint finish. Increased storage of glycogen or increased storage of glucose. Again, that's going to help with the lactate system due to the fact that it uses glycogen, as well as the aerobic system, because that also uses glycogen to produce ATP. It's just going to be able to have, it's going to make the athlete be able to perform for longer at high intensities. And finally, increased number of mitochondria. Remember that mitochondria is where aerobic capacity takes place, or like aerobic production actually takes place within that mitochondria. The more mitochondria we have, the better able we are to perform aerobically, which is really important for performers such as a marathon runner or triathletes, etc. You need to remember with mitochondria, we also have myoglobin. Myoglobin is that protein that transports oxygen to the mitochondria. So an increase in mitochondria, if you remember the adaptations to the muscular system, we also get an increase in myoglobin. How are we going to remember the adaptations to the energy systems? You've got to think when you're performing, when you're playing sports, whatever sport you're playing, what drink do you have on the side? You probably have a Lucozade drink or something like that, okay? And we've used this before in class. I'm just going to remind you of it. So adaptations of the energy systems, you have to think energy systems, energy drink. You think of energy drink, Lucozade is going to be the energy drink you think of. So the L stands for lactic acid tolerance increased. Okay, that's all to do with the lactate system. The U is utilization of fats. So we've got an increase in fats usage. That's to do with the aerobic system. The C is creatine stores increase, which helps the ATP-PC system. The A, remember we're spelling Lucozade with an A as opposed to an O for this memory method to work. The A is aerobic energy system, and I've spoken about how that's going to help with um, performance. And then the last one we have to think about is Lucozade as a whole. What does Lucozade have in it? It has loads and loads of glucose. If you read the ingredients, you have three here. I've pointed out three parts where it says glucose within the actual advertisement for Lucozade. Glucose, you think glycogen. We have an increase in glycogen stores and an increase in number of mitochondria, which is to do with the aerobic energy system. Hopefully, that's quite a clear way for you to remember the energy system. Hopefully that helps you with these questions. So right now, there hasn't been many questions on the adaptations of the energy system. However, I've got two for you here. So first of all, that's gone on backwards. So you've got the answer first. Fantastic. Don't worry about that. If you just look at the question, you actually look at the answer and understand what they wanted as an answer. Now remember what I've said to you at the start. First of all, you look at how many marks the question's worth. This is only worth 2 marks. Now, if you think, I know quite a lot on increased glycogen storage, but I have no idea what they want to hear. Just put as much information down as possible. They're not going to punish you for that. Just make sure you don't spend too much time on it because remember, we've worked it out, it should be about 1 minute per mark is what you want to be spending on in the exam. Now this next question, hopefully I've actually set this up correctly. Here we go. This is from the January exam. Now, I'm not saying to you, don't bother looking at this. However, because this was the question in the January paper, it may not come up in this summer one because people are going to be redoing it in the summer. However, it's important to look at it. Okay, so Paul is a football player. He has completed a pre-season training plan resulting in long-term adaptation to the cardiovascular and energy systems. Analyze how long-term adaptations of Paula's cardiovascular and energy systems affect her football performance. 8 marks. This is the last question of the paper. So all you need to do is circle important information, analyse, so you're going to have to say a lot of information about it. Cardiovascular system, concentrate on step by step. So first of all, concentrate on the cardiovascular system. Now remember the memory method, 1, 2, 3, 4, 5, 6, 7, not 7, 1, 2, 3, 4, 5, 6, 8, 9. Write those down, try and work out which ones are the cardiovascular system, and then all you have to do is speak about those for the cardiovascular system. And then for the energy systems, hopefully you think energy systems, energy drink are Lucozade, and then from that you get lactic acid tolerance increases, utilization of fats, creatine stores increase, and then hopefully from that you can actually discuss how that's going to improve or affect Paula's football performance. So give that a go, pause this, and I'll go through the answer with you. So this is what the student that answered the question wrote. First of all, capillarization at the alveoli and skeletal muscle would be very important to Paula's football performance. This is because it produces a larger surface area for gaseous exchange and occurring meaning of oxygen. I know you can read, so just read that through. Highlight key points that you've highlighted. This is the second part of it that's going to go over this question. I just couldn't fit it all on one page. And there's the second part, which actually ends up finishing from the bottom line performances. It would mean she could perform high intense activities for longer, and it continues from there. So have a look at that, and hopefully this screencast will help you. This is the last screencast you have to do with regards to actual kind of learning and memory methods, etc. The next screencast I'm going to go through is going to actually talk to you about the final question that's actually going to be asked of you, and synoptic question, and how hopefully not how you're going to answer it, but more how you're going to prepare for it and what you need to be prepared for. So what you really need to be revising the last couple of days. Okay, thank you. Bye.